So I'm opening up my book, which has good problems, just similar to what's on the computer in my math lab. That's kind of where they come from. And so I'm going to, like I said, kind of step in here to 2-3. And, you know, what we learned was to try to solve these systems of equations. So I'm going to grab one here. Like this. 4x minus 5y equals negative 17, and 3x plus 2y equals negative 7. And the question is, solve this system of equations. So we got to this last class, but this is kind of where we ended last class, so we can work on this a little more. I also got some good word problems I need to do today. I didn't get to those last class. Solve the system of equations. Well, we had 3 methods. We could set them equal to each other. These aren't really set up to set them equal to each other. I could manipulate them to get them to where I could set them equal to each other, but that's too much work. I would not take that approach on this problem. I would not. But you could. You could substitute. You know, substituting would require you to solve for y or solve for x in one of the equations and substitute it into the other equation. That you could do that. It would work. But again, I feel like that's a little too much work. So I'm going to go with the third method. It's called the elimination method. I'm going to try that. I'm going to try to multiply one of these equations by something so that I can add these up and eliminate a variable that way. The truth is, I can't multiply this by anything that'll get it to match this, or not anything nice. You know, I didn't even show you this last class, but you can actually multiply both equations by something. Like, maybe I'd like this to be a 10 and this to be a 10, or, you know, actually a negative 10 and a positive 10. What could you multiply by to make that happen? You'd have to multiply this guy by,
Negative 2.
well, how about a 2? Yeah. Let's multiply him by a 2. The purpose is to get a negative 10y. Then what would you multiply this by? A 5. The purpose is you would have a positive 10y. And then you could eliminate those variables. But this, so that's cool. That's good strategy. That's the elimination method. You're allowed to multiply an entire equation by something. You're allowed to multiply both entire equations by something. And then you alter the look of the equation. There is some rewriting to do here. Now they look like this. 8x minus 10y, when you multiply by 2, equals negative 34. The second equation is 15x plus 10y equals negative 35. And now you add the equations together. And it works. This method works. The y's eliminate. That's the point of the elimination method. When you add them, they eliminate. You get 23x equals negative 69. Divide by 23, and it goes in evenly. You get negative 3. Awesome. Awesome. I mean, that's about as hard as it can get. Well, I guess if the answer would have been negative 3/26, I mean, that would have been a little tougher answer, but still an answer. The procedure is the same. We're not finished. Once you get x, you also need to find y. You're looking for both variables. You're looking for the ordered pair. And I would take that x now and go substitute it back into one of the original problems and try to find y by substituting him back in. It's really easy. I'll just go to this bottom equation. I'll take that x and plug it in there. It's negative 9 plus 2y equals negative 7. And now I solve. So I take this and I call that back substituting back in one of the equations. If I add that 9, that's a 2. Divide by 2, y is 1. We're finished. We found the answer, 3, 1. Oops, negative 3, 1. Negative 3, 1. one more time. This is how you should do this problem, I think. This is how you should do this problem. I mean, there's other ways. I don't want to do it a bunch of other ways. But one more thing. Behind the scenes, I'd like you to remember or recall that that's a line. If you graphed it, he's a line. If you graphed it, he's a line. And what you just found is the point of intersection of these two lines. So if there was a graph, if there was a graph, I don't even know what it would look like. But we just found -3, 1. That's not quite to scale there. But -3, 1 is the point of intersection. Those probably aren't accurate. I just drew a couple lines. Yeah. Cool. Let's try another one. Let's try another one. Here's one. 4x minus 8y equals, I'll just grab this out of the book here, which is a lot like your homework, equals 5. 6x minus 12y equals 10. 6x minus 12y equals 10. All right, another system of two equations, two variables. Solve the system of equations. The way it's set up, I think I want to do elimination method again. You know, sometimes it's set up where I'm ready to substitute. I wouldn't substitute on this one. I would do my elimination method again. So that means I want to add them and try to eliminate somebody. If I'm going to add them and try to eliminate somebody, I gotta manipulate. I gotta multiply by something. Any ideas? Any good ideas? Oh yeah, so try to get to a 12, she's saying. So maybe multiply this guy by a -3. That'll give me a -12. Maybe multiply this one by a 2. That'll give me a +12. I am trying to make them have different signs because I want to add them and eliminate. All right, that's a good idea. So now I'm kind of going this way, if you don't mind. Here I go. And I get a -12x. Positive 24y equals -15. You got to be careful with that. I mean, I know it's just multiplication, but you want to do it correctly. Down in the bottom, I'm multiplying by a 2. That's a 12x and a -24y and a 20. This is kind of awesome. Watch what happens when you try to add these to eliminate. The x's eliminate. That was our goal. We get no x's there. This is weird though. The y's just eliminated also. And over here, these numbers add up to 5. And so I'm staring at an equation that says 0 equals 5. Okay, I warned you about that last week. So when that happens to you, and you're staring at a false statement, I mean, that's the question now. Is this true or is this false? Oh, thank you, that's false. And if you're staring at a false statement, then that means the answer is no solution. So, there is no solution. And the official answer is no solution. I'm going to put another word here called inconsistent. That means this system of equations was an inconsistent set of equations. There's no solution. The system of equations was inconsistent. And visually or graphically, these are two lines that never intersect. What does that mean? They're parallel lines. So I'm going to put that phrase here. Now, your homework, and you don't need, when there's no solution, this is the word, this is the technical word for that, but this is the kind of common sense. This is what's going on. These lines don't intersect. There is no point of intersection. There's no solution to this system of equations. They're two different lines, but they actually happen to be parallel. You know, that's not real easy to see, but you can sort of see the ratio between the x and the y coefficients. You can sort of see maybe that they would have the same slope. I mean, the slope's not there. If you solve for y, you see the slope, but you can sort of maybe see that ratio will lead to the same slope. So anyway, yeah, they're parallel lines, and there's no solution. So we're done. Cool. Okay. All right, well, let's check out one of these word problems. And I've got some in the book. I'm looking at the book. Like I said, the book is the same thing as the My Math Lab. A lot of these questions are just typed in there, I guess, the homework. So I can look at this book and come up with some good problems. Here's one called Breakeven. This starts off a little easy here. I'm in 2.3, and I'm doing a little word problem called Breakeven here. And I'm not going to write the whole word problem, but I'm going to read it to you. It says, a jewelry maker has total revenue for her bracelets given by this function, R equals 89.75x. R equals 89.75x. They told me that. They called that revenue. Thank you. They labeled it R. I should know that's revenue. That's a jewelry maker. That's her bracelets. By the way, what do you think X is in this problem?
Number of units.
X is the number, right. Thank you. It always is in these kind of business type problems. X is usually the number of bracelets in this case, the number of units, the number of things we're building and selling, and right. So in this case, it's the number of bracelets. That's X. Anyway, what else is going on? Oh, she has a cost. She has a cost of 2350x plus 1192.50. She has this cost of 2350x plus 1192.50. Right. Okay, that's her cost. All right. This revenue and this cost are both dollars. You know, they're dollars. Okay. X is the number of units produced and sold, number of bracelets produced and sold. Cool. That's what they tell me in the problem. Anyway, it says to use graphical methods to find the number of units that gives her the break even for this product. Okay, I don't want to use graphical methods. I don't. I want to do algebra. I want to do work. I don't want to graph it. And so what's the concept? Break even. What is that going to mean? She's going to break even when, what does that mean? Break even? I previewed that last week. You know what it means, I think. What does break even mean? What'd you say?
N equals 0.
When what equals 0?
Both these numbers up here.
Yeah, not quite. Now hang on. Break even is when the profit equals 0. That was an idea, and that's what I wrote on the board. When the profit is 0, you break even. I mean, for a while, you might have a negative profit. You're losing money. Then you break even. You got 0 profit. And then you start making money. You got a positive profit. So you can have a negative profit. You can have a positive profit. But right there in the middle, when your profit is 0, you break even. But what I said was this. If your profit equals 0, you break even. Now, what the hell is profit? Do you remember what profit is? Revenue minus cost. Revenue minus cost is profit. So if the profit is 0, that means the revenue minus the cost has to be 0. And if you move the cost over, that means that the revenue has to equal the cost. So to me, there's two ideas to break even. Your profit is 0, or said another way, same thing said another way, your revenue equals your cost. So there's two big ideas. I mean, it's the same idea written in two different ways. To break even, it's either one of those two. They didn't mention profit in this problem. I can build profit. If I have revenue and cost, I could build myself a profit function and I could set it equal to 0. But let's just skip over profit. It wasn't mentioned. I don't need to mention profit. Break even is when the revenue equals the cost. So when does this revenue equal this cost? So now I am in this phrase where I'm setting them equal to each other. So not a hard problem at all, but you have to know what to do. When someone says break even, you set them equal to each other. Revenue should equal cost. And then it's easy. There's nothing to it. You subtract, you divide, you do a little bit of algebra. I'm going to subtract this over here, right, you guys? 89.75 minus that 2350 is 6625x. Equals this 1192.50. I would divide by 6625. And x is, I need a calculator. 18. So she's in this business, and once she sells 18 bracelets, she finally broke even. So she'll be looking forward to selling number 19 and number 20 and number 21 and number 57, and she'll make money. But she has to sell 18 bracelets before she even breaks even. Makes sense? Everything makes sense, right? It's logical, it makes sense. It's interesting, sort of. Cool. I don't really, like this problem. I found X and then I plugged it back in and found Y. I mean, the answer is an ordered pair, in a way, I don't really necessarily need an ordered pair. I mean, I think this is just, when do these equal each other? What X value? I don't think they need the Y value. I think they just want the X value. But it depends on what they ask for. What did they ask for? Find the number of units. The number of units is X that makes it break even. If you did plug it back in, you would plug it back in here and you could find out what your cost is for 18 units. And you could plug it back in here and find out what your revenue is for 18 units. They should be the same. They would be the same. We set them equal to each other. So that was real easy. Real easy. I'm thinking of a way to make it a little tougher and to also make you Listen, I'd like you to know this. I'd like you to know this, and I think we'll work on this all semester. We'll talk like this. But, the revenue is the money you bring in from selling X number of things. Well, then it turns out that's the price. That right there is the price. I mean, because revenue is the money I take in. So if I sell one thing, I bring in $89.75. What did I sell it for? I sold it for $89.75. If I sell two things, it's 2 times 89. This is my retail price. That $89.75 is the price that I sell them for. So that's very logical too, but I'd like you to kind of know that. I mean, they didn't make you think about that. They gave you the revenue function. They gave you the cost function. I'd like you to maybe think a little more. I'd like you to think about it, and maybe I would set up a problem where maybe I didn't tell you the revenue function, but I told you the price I was selling it for. If I tell you the price I'm selling it for, that's your revenue function. It's the price times X. The price times X. By the way, this cost function, let's analyze it a little bit closer. If I build 0 bracelets, I've said this last chapter, I said this a few times. If I have 0 bracelets, how much does it cost me? Well, you plug in a 0 and you have this bunch of cost here. So you have a bunch of cost even though you haven't built any bracelets. Again, that's your warehouse, that's your machines, that's your employees, that's your equipment, that's your wires and your rocks, whatever you're building your bracelets out of, diamonds. Well, anyway, you know what I mean? That's your cost. You haven't even built any bracelets yet. That's your original cost. or let me call that a fixed cost. Fixed or original cost. The reason it's fixed is because it doesn't change. But cost does change. Cost changes for every damn bracelet I build. When I build one bracelet, I add to that cost. When I build one bracelet, I add $23.50 to that cost. So that $23.50, which is the slope of the line, of course, is the rate of change of my cost. It's the slope. It's the rate of change of my cost. And so it's the variable cost, you could say. It's the cost per unit. Do you agree with that? Every bracelet I make costs me how much? $23.50. Every bracelet I make costs me $23.50. Well, plus this original startup cost. But each bracelet costs $23.50. That's the diamonds and the gold that go into that bracelet. Cost me $23.50. Then I sell them for this much. That's a hell of it. That's nice. It cost me $23.50. I sell them for this much. I make some money, but I make a lot of money. But it takes me 18 bracelets before I recoup this original cost and finally break even. You heard that whole story? But my point is, rather than just giving you a cost equation, I'd like you to think about the cost equation as what it is. I mean, maybe I would state a problem with more words, and you would have to write these. If I gave you a price, you could write the revenue function. If I gave you the cost per unit and an original cost, you could write this equation. This is the cost per bracelet. Or the cost per unit. In this case, it's bracelets. So, I don't know, it's nice if I just give you the definition, but it's also nice if you knew a little bit about these things. And they're not hard, they're easy. They're linear equations. But these numbers do mean something. There's a price, there's a cost per bracelet, there's an original fixed cost. But we've been talking like this for a couple weeks. This is good. Let's do another kind of word problem. You know what? Here's what I'm doing. This is they got these mixture problems. Okay, so I'm making up a mixture problem for you here. Mixture problems. We used to do these in intermediate algebra. Maybe this is, you might remember this. A mixture problem. Let's see. I'm going to try to mix up a party drink. I'm mixing a party drink. Non-alcoholic party drink. No alcohol. So what I want though is I want it to have, I want it to be 35% grape juice. That's what I want. I have 5 gallons right now of some stuff that's 18% grape juice. How much pure grape juice should I add? How much pure grape juice should I add to it? I have 5 gallons of this stuff. How much pure grape juice should I add to it to get what I want? Okay, these are good problems. Might have to teach you how to do this. But I'm taking a 2-minute break. I'll be right back.